So for people watching at home, I've made a video for exercise 14C.1. So they were yesterday's questions, so you might want to watch those and complete those questions if you haven't already. I'm going to go through a couple questions from 14C.2, and then these are the questions that the guys in class are going to be working through today. So I'm going to start off by doing question 6, where we have matrix M, which is equal to this, N and I. And 6a asks us to do Mn. So we're multiplying these two matrices. Now with all these matrix multiplications, the first thing you need to check is the order of each matrix. So matrix M is a 2 by 2, and matrix N is a 2 by 2. Remember, those two inner numbers are the numbers that we need to be looking at. If they are the same, then we can do that multiplication. So in this situation, we can definitely do that multiplication. And the resulting matrix, you look at the two outside numbers, is going to be 2 by 2. So I'll write down these values. So this is question 6a. And we're doing Mn. So M is 5, 1, negative 2, 3. And N is negative 2, 0, 3, 4. Alright, so like I said, since this is a 2 by 2 and this is a 2 by 2, we can do the multiplication because those two numbers are the same, and our resulting matrix is going to be a 2 by 2 because that's what those two values there tell us. So we start off by going this value here multiplied by that value there. So 5 times negative 2 plus that value there multiplied by that value there. 1 times 3. And that tells us our first component of that matrix. So that there will be our first number. Then we have to go 5 times 0 plus 1 times 4. So that will be this position of the matrix. 5 times 0 plus 1 times 4. So that's our top row done. And remember, our resulting matrix is going to be 2 by 2, so I've still got 2 more positions of the matrix I need to work out. So now I use this number here, this negative 2, and I go negative 2 times negative 2 plus the 3 times, the 3 times the 3. So that times that, that times that. So it's going to be negative 2 times negative 2 plus 3 times 3. And then the final position, we're going to go negative 2 times 0 plus 3 times 4. So the negative 2 times that 0 plus 3 times 4. And then it's just a matter of simplifying that matrix. So 5 times negative 2 is negative 10 plus 3. Negative 10 plus 3, because 1 times 3 is 3. Then this one, 5 times 0 is just 0 plus 4. So that's going to be 0 plus 4. This one here, negative 2 times negative 2 is positive 4. Plus 3 times 3 is 9. And then the last one, negative 2 times 0 is 0. Plus 3 times 4 is 12. And then it's just a matter of doing this. So negative 10 plus 3 is negative 7. 0 plus 4 is 4. 4 plus 9 is 13. 0 plus 12 is 12. So that's our resulting matrix. Alright, so that was Mn. So we did that one times that one. Now, if I do Nm, So this one is going to be in front and that one is going to be behind. Do you think that we get the same resulting matrix? No, we don't. Alright, so again, just because I want you guys to see me do a few of these, just so then the process is instilled in you, I'll do NM. You can kind of do it as I'm doing it if you think you're understanding it. So N is -2, 0, 3, 4. And M is 5, 1, -2, 3. Again, both of them are of order 2 by 2, therefore we can do them, and the resulting matrix is again going to be a 2 by 2. Alright, so can anyone tell me what the first sum will be? What are the two multiplications that we're going to do? Good. Perfect. So -2 times 5 plus, so you went that times that plus that times that. So 0 times -2. Then we go to our next position, -2 times 1 plus 0 times 3. So -2 times 1 plus 0 times 3. Then from matrix N, what's the next number that I'm going to focus on first? Good, so I'm going to go 3 times the 5 plus 4 times the -2. So 3 times the 5 plus 4 times -2. And then finally, I go 3 times 1 plus 4 times 3. So 3 times 1 plus 4 times 3. And then it's just a matter of simplifying each of those. So -2 times 5 is -10 plus 0 times -2 is 0. -2 times 1 is -2 plus 0 times 3 is just 0, so that's going to be -2 plus 0. This one's going to be 15 plus -8. And this one's going to be 3 plus 12. And therefore we get -10, -2. 15 minus 8 is 7. And 3 plus 12 is 15. So you can see that our resulting matrix NM is different to what our matrix MN was. So the process of multiplying them definitely depends on their position. You won't get the same matrix either way. Now, part C wants us to go M times I. So matrix I here, we actually call this an identity matrix. So whenever we have ones along the diagonal, if we've got a square matrix with one coming along the diagonal and all the other values in the matrix are 0, that's what we call an identity matrix. So this thing here is called an identity matrix. If this was a 3 by 3 matrix and there was ones across the diagonal and all the rest of the inputs were 0s, that's still an identity matrix. So this here is called an identity matrix. Now one property that we'll soon see is if I multiply a matrix by an identity matrix, so if I go this times this, the resulting matrix is actually just going to be whatever our initial matrix was. So if I do this one times this one, I'm actually going to get what the initial M was. So I'll just do that so then you can see it happen in practice. So we're going to do M times I. So M is 5, 1, -2, 3. And I'm going to multiply it by I, 1, 0, 0, 1. Alright, so see how the 1s come across the diagonal, the other two inputs are zeros? That is called an identity matrix. So, like I said, I'm expecting, once I do this multiplied by this and simplify it, I should just get my original M matrix. So we'll see if it works. 5 times 1 gives me 5 plus 1 times 0 is 0. Then I go this times this plus this times this. So 5 times 0 is 0 plus 1 times 1 is 1. Then I come down to my -2. I go -2 times 1 plus 3 times 0. So -2 times 1 is -2 plus 3 times 0 is just 0. And then finally, -2 times 0 plus 3 times 1, which is just 0 plus 3. Alright, so let's have a look. Hopefully, if I've done this correctly, after doing that multiplication, we'll get our initial matrix M. Is it the case? 5 plus 0 is 5, 0 plus 1 is 1, -2 plus 0 is -2, 0 plus 3 is 3. Is that the same as my matrix M? Alright, so whenever we multiply a matrix by an identity matrix, you always just get the original matrix. So just to reiterate what I've said about identity matrix, and an identity matrix is a square matrix in which the elements are, the elements in the leading diagonal are 1 and the other elements are 0. So this is a 2 by 2 identity matrix. See how we've got 1 and 1, the other two inputs are 0. If we have a 3 by 3 identity matrix, see how the diagonals are all 1 and then all the other inputs are 0. And that they use the letter I to represent an identity matrix. So that's one other thing to be aware of. Now this example here is pretty much what we've just done. They've got some matrix, they've multiplied it by an identity matrix, and what do you expect the multiplication to give you? The initial matrix, and that's what's happened there. And then, even if you do it the other way around, so they've got the identity matrix in front, then they multiply it by the matrix, and you can see the result is just that matrix there. Alright, so that's all of the new content for today. I want you to work through, I don't want you to start at question 1 of 14C.2, I want you to start at question 4. Alright, do 4, 5, 7, E and F, then you can come to 3 and then do 8. And then 1 and 2 at the end, if you get there, which you probably won't. But over the break or at some time, I'd like you to do these questions because they're going to be good for your practice.